Hello, everyone. So today we're going to be learning a little bit about the Younger Dryas event. So what was it? 14,500 years ago, in a period called the Pleistocene, Earth was transitioning from cold and full of glaciers to much warmer conditions. And during this warming, there was a short time where the northern hemisphere suddenly cooled down. And this is known as the Younger Dryas event. So down here, we can see an image of the distribution of land masses during the Pleistocene. And on the left here, at the very top, we can see the Holocene, which is the current period that we're in. And the Pleistocene just below that is when the Younger Dryas event occurred. So this event was named after the Dryas flower because this flower became so widespread during this cool period. And this is because this flower is very resistant to frost and it thrives in Arctic conditions. So it is present today in areas with very cold conditions, such as Greenland, Iceland, and Canada. So before we talk about what caused the Younger Dryas event, let's cover what thermohaline circulation is. So Earth's oceans have a global web of currents that are caused by differences in the water's density, and this density is determined by temperature or thermo. And currents are also caused by differences in the amount of salt in the water, or salinity, or the haline aspect. So we have thermohaline circulation. So, colder, denser water sinks in polar regions, while warmer, less dense water rises elsewhere. And this creates the continuous global ocean circulation system of these currents. And on the right here, we can see just a little overview of thermohaline circulation. So, why these currents are important is they play a very large role in the entire Earth's climate system. These currents redistribute heat, nutrients, and gases, such as carbon dioxide, across all of Earth's oceans. So, for example, the North Atlantic Drift Current warms Europe, keeping their winters a bit warmer compared to places at similar latitudes, such as Canada. So, disrupting thermohaline circulation would mean extreme changes to weather, such as stronger storms, changes to rainfall patterns, and temperature changes across the globe. So, with this North Atlantic drift example, if thermohaline circulation was disrupted, this current would no longer warm Europe, and their winters would be much colder than they are today. So, now let's get into what actually caused the Younger Dryas event. So there are many hypotheses, but the most widely accepted is that the Laurentide ice sheet began to rapidly melt, adding cold, fresh water to the Atlantic Ocean. So on the left here, we have an image of this ice sheet, which covered what is modern day Canada and a little bit of the United States. So this large amount of cold, fresh water, meaning water with little to no salt content, entered the Atlantic Ocean and disrupted the thermohaline circulation. So, this initiated a return to glacial conditions or the cooling that we saw during the Younger Dryas event. Other hypotheses of causes of this event are volcanic eruptions and a large comet impact, although there are other hypotheses as well. Eventually, the amount of fresh water melt from this ice sheet did slow down, and the thermohaline circulation was restored, leading to the recovery of the climate. So, why should we care about this event? It was 14,000 years ago. Well, global warming and climate change are very serious issues in our modern world. Global warming leads to a large amount of melting ice, such as the Greenland ice sheet, which we can see an image of here on the right. So, Greenland ice sheet melting not only leads to rising sea levels, but it also leads to an increase in the freshwater flow into the Atlantic Ocean. So, this can disturb thermohaline circulation, which is very similar to what we saw occur in the Younger Dryas event. But the cause of the melting today is different than the Younger Dryas event. The cause of melting today is because of high emissions of fossil fuels. If these high levels of emissions continue, ice sheets will continue to melt and likely disturb thermohaline circulation and global weather patterns. So, from this, we can learn that climate change doesn't always mean global warming. It can actually show the opposite, such as what we saw in the Younger Dryas event, which is a period of rapid cooling. But there is still hope for today. There are many efforts being made to decrease the effects of climate change and global warming. So, this includes reforestation, shifting to renewable energy, and decreasing greenhouse gas emissions, which can all help to slow down the melt rates of ice sheets. So, overall, we should continue to prioritize these efforts in order to protect our thermohaline circulation and global weather patterns as a whole.